Fun, folks. This is the real thing I've been waiting for. Doing a little Solidity, guys. We're gonna dive in. We're gonna build. I'm gonna learn in public about some Solidity. And then hopefully, obviously I'm building a ton of stuff between the backend engineering. We're learning that proper. And then the SaaS product, the Code Chronicles, we ended up on Team Syncer, full stack SaaS product, obviously smaller scale version of something, but we got authentication. We got many relationships. We got a lot done there in that. And a lot of knowledge was across that series. And then the new series, the Build a SaaS is fun. And I'm going to dump all this knowledge, I think, from the backend series of learning Python and then hopefully Golang and Docker and Kubernetes into that series. So that's going to be a fun one. And guys, I want to get on the smart contract stuff. This is really why I became an engineer, was learning blockchain stuff, was deep down the initial reason why I even got into software. So I went on this journey of learning front end, becoming an engineer in that field, and then getting paid for some small kind of full stack work, and then inevitably getting hired as a full-blown professional front-end engineer at an enterprise company was awesome and really enjoyable. And then going on to do freelancing stuff and contracts for more stuff beyond that. But that was all largely front-end stuff. Again, so kind of honing in the back end is super important, I think. And then this is the series that I really deeply want to just like live. Like I would, the goal is to be an entrepreneur, build my own products, all that stuff. But I would 100% be okay with being a blockchain engineer for a company, 1,000,000%. So we're going to dive in. We're going to start at the very fundamentals of this Alchemy University, and I'm going to zoom in for y'all. It's a very, I believe they have all their stuff on like EVM, Ethereum, Solidity, JavaScript. They're powerful. They're a great tool. So look into them. If not, I'll have obviously all this stuff covered on my channel with other things embellished within it and TypeScript and a few other things on my channel. But so let's dive in. Let's look at storage variables in Solidity. We're going to look at storing variables. Let's read it. Okay, so let's begin with storage variables. These variables are stored in a contract's permanent data storage on the blockchain. Fun. When you modify a storage variable in a transaction, the updated value becomes globally accessible for subsequent reads and interactions. In Solidity, declaring a storage variable is as simple as declaring the variable inside of the contract. So a contract is basically like a class. If you're maybe accustomed to other things, what type of variables do we have? We have uint8, uint64, uint30. I will say my address is an address variable. We got strings still. We can say my name for that. Sweet. Okay, so let's see what they want us to do. The contract now has a Boolean storage variable called myVariable. Okay, we'll build that back out. Put it back. Quit breaking the code. Okay, so Boolean, myVariable. Sweet. All right, curious about the initial value of myVariable. Since it's uninitialized, its storage location holds 0x0. In Solidity, that results 0x is, what is that on the blockchain what's it called? What is 0x called on the blockchain? There's these codes, I forget what they're called. We'll probably cover it here, but there's these codes. I forget if like 5B in a contract is one of them. Codes on blockchain. So I just want to see this real quick. OX and let's see, 5B. I forget what they're called. They're called codes, script codes, blockchain codes. This is not going to be it. Okay, but there's a list of codes. I'll have to find it. Or I'm sure it's within this course. Okay, so curious about the initial variable. Okay, so since it's stored, it holds 0x0 in Solidity. That translates to a default value for Booleans like myVariable. The default is false. Therefore, upon contract deployment, this myVariable Boolean value will be false. Okay, so now we're going to do two things with the variable. We want to assign it to true, and we want to make it public. Okay, and it looks like we need a semicolon. See how we added the public keyword here? This automatically creates a getter function for the variable. Now we can access the value in my variable by calling the function on the contract with that very name, my variable. Okay, cool. So it looks like we can build a function out of that if we wanted, and it would just be the Boolean value of that, I suppose. So what does that say? Your goal, add 2 Boolean variables. Guys, I got to move my face. Your goal, add 2 Boolean variables, create 2 Boolean storage variables on the contract A and B, store true in the variable A and false in the variable for B. Golly, look at this. Guys, we're going to do some coding here. So bool, we got that one to be true, right? Okay, cool. So Boolean A is true. Do we need it to be public? Do we need the getter out of it? Is the question. We got bool B equals false. So I suppose we can not do a bool B or public B, or we don't need to assign it to anything. We can just go ahead and pop it in as B because its default value is false. Okay, let's try to run the test, see what we need to do here, if we need to make it public or whatnot. Remember, A is not, and then we also have to, add them, right? Create two public, add two Boolean values. Guys, this is a whole deal right here, right? Let's see. I'm not sure if we're following the instructions. We broke it somewhere. We've done bad. Okay, so A plus B, let's see. A plus B, what does it want us to do? Our goal, add two Boolean variables, create two public Boolean variables. Okay, we've done that. On the contract, A and B. Store true in the, okay, so we'll just do that. Did we do it? Guys, it was a user error. It was a user error on that one. So we've done it. We've done the deal. Onwards, upwards, and onwards to unsigned integers. Fun. Okay, so unsigned integers. What the heck is an unsigned integer? I was just wondering that. That's crazy. I was just wondering that. First, let's go over integers. Integers include all positive and negative numbers without fractions. These numbers, or the numbers -2, -1, 0, 1, and 2 are all integers. This range continues on both pods. So -50, -10, -12, 20, 25, all numbers. So to determine if the number is above or below 0, we can use the plus or minus sign. Unsigned integer is an integer that has no sign. Okay, so uint for unsigned integer. A uint can be suffixed with the number of bits reserved for it. For instance, a uint 8 means that there are 8 bits provided for this value. So that's for the binary code. The bits, each 0 and 1 is binary. So for, what do we call, like each bit, that's a bit. You have zeros and ones, obviously, in computing. But if we have 8 bits, this is one number, and then this would be another number, 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 this would be, that's binary, right? Is 8 bits of zeros and ones. Okay, so 8 bits can range from 000 to 1111. This range can repeat itself for 256 unique values. Okay, so I believe what it's saying here is, okay, let's keep reading those. Since the range of unsigned integer values do not include negative numbers, it is simply 0 to 255. In decimal, the unsigned value of 0, why is it 0 to 255? Since the range of unsigned integer values does not include negative numbers, it is simply 0. Wouldn't it be 0 to 9? No. Okay, so in decimal, the unsigned value of 00000 and the value of 11111 is 255. Okay, so let's put a little comment here. Let's pretend we understand what we're reading, right? So this first number represents 0, okay, and this last number represents up to 255. Cool. So the max for this is a uint 8. So any numbers between 0 and 255, the type is a uint 8. So the same way when we built that type for a variable, we said bool, the type is a Boolean of true or false. When we built that Boolean variable, that my variable, if we want to build a variable that is a number, so let's say maybe the variable we want to build now is going to be the price of your crypto, right? So crypto price, that's an integer. Let's pretend it's not a decimal, so it's not a float. It's a whole price, so it's either $1 crypto or $2 crypto or $10 crypto. If the price is up to, let's say, $200, it needs to be a uint 8 variable. So that's the type that is for an integer for a crypto price. It is so there's different variables within. Maybe I should preface this because I feel like this is the beginning of a Solidity deal. But if fundamental programming is not maybe something you've studied, check out a quick JavaScript course for just like a week or two. Hop back into this or I'll even make a JavaScript course. But to define variable types, right, between a Boolean variable, a string, right, these are all different types of data. So you have strings, like this would be a string is a hello message, a number is a uint, a true false value is a Boolean. And there's more, and there's floats and a few others. So these are all different values. This would be a string variable. So we'd say string, like my name, and we can hard code it to Ryan or Pegs. Here too, we can say uint 8 equals, we can say my number, if you will. equals 1, right? And my number, we can literally name this whatever we want, but we cannot name the data type whatever we want. The data type has to fall under the specific data that this is, whether it's a number, a string, or whatnot. And then this would be my Boolean, and this would be true or false. So that's just a little quick lesson. If for those unfamiliar with JavaScript and the syntax of some programming stuff, but I think JavaScript would be very, very, because this is very similar to a class. A contract is very similar to a class. These variable types, it's just TypeScript and Solidity. So, but okay, let's keep reading. Sorry guys, that was a bit of a tangent. I like to teach little tidbits while we learn to really just properly learn something. Okay, so the value of 0000 is one number up to 255 negated by, again, we have like all these different numbers that would all, not two, excuse me, but these would all represent different numbers, and so on and so forth up until that 1 ones for an 8-bit value. Okay, so the max value of a uint 8 can store is 255. You can calculate the max value of uint by doing 2 raised to n minus 1, where n is the number of bits you can use to store the value. Got it. Okay, so 2 to the 8th then would be, right, what is 2 to the 8th? Is that 255 minus 1? So let's say 2 times, let's just do some math real quick. So we need, that is times 2. So that's 4 2s. Let's do 5, 6, 7, 8. And that should be 256. Then minus 1. So that is a good thing to remember when building these quick values. Because if, let's say if we're building a variable for a price of like Bitcoin of like 32,000, well, you can't use an uint 8 for that because 32,000 is much larger than 255. So that would be a little bit different. So okay, we've understood the math of it. Let's look at the goal now. Guys, and mind you, this tutorial, like I'm going to pause. I know I take a lot of pauses. The goal here is to like make you guys really, really competent and make myself really competent. That's the goal. So this is a slow turtle moving tutorial, like slow series. This is not going to be something of like, oh, just power through, you'll get it done in a month. This is like, no, we're going to really grind this out and understand these things granularly. Because when you understand something granularly, like, oh, where does the uint 255, where does that thing uint 8 come from? When you understand something at a deep, granular level, you can really build from it. You can really deeply build on top of it. And you're like, oh, this is why I'm doing this, boom, boom, boom. And some people in software have said, oh, you code really fast. And a lot of engineers do. People, I know guys, there's this guy, Eddie, so much more talented than myself. Many guys more talented than myself. But the only way I'm somewhat able to code at a decent speed when I'm like really writing software is because I understand what I'm doing for what I understand. When I don't understand what I'm doing, I have to figure it out, and wrestle with it and stuff like that. But it's so much better to move slow and you really build a deep competence than when you build on top of that, a little brick on top, a little brick on top, a little brick on top. When it's time to really build something, it's like, oh, we will be, it'll be proper. It'll be proper. So that's why I'm kind of going on these tangents and breaking things down and seeing how it works and trying to show you guys that stuff. So we're going to move slow, but we're going to move proper. Okay, so your goal is to create unsigned integers. Let's create 3 public storage unsigned integers in our contract A, B, and sum. Define a variable A. Okay, so we'll do that. So we'll say uint 8 as A. We need our semicolon. And it needs an initial value between 255, so we'll say 216, between 0 and 255, or 215, that's perfect. So define a variable B, uint 65, and it needs to be above 255. So we'll say uint 16, so variable B, and we'll say 322. And the variable sum should be a uint 256, okay? And this will equal A and B. Let's try. Let's try to run our test, see what we got. Da, 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 da. Why are we okay? What's going on here? Oh, is this throwing us off a bit? What did we do wrong, folks? What did we do wrong? Member A not found or visible after argument dependent my contract. We don't have a my contract. We have my so. Oh no. Okay. What did we do wrong, folks? What did we do wrong? What? Okay, so the variable sum should be a uint 256 with the sum of the values stored in A and B. Yeah, we've done that. What the heck? What? Okay, so member A is not found. What's going on here? Let's see what our solution is. Yeah, where did we mess up? What the heck? Oh, we needed public. It was user error again, folks. It was user error again. Good to know. Good to know. So we're going to move even slower. You know what I mean? We got to get the public variables in there. That's important. That's important. Okay. Cool. All right. We got unsigned integers down. We got it down. So to the next stage, to signed integers. Now that we know what an unsigned integer is, let's take a look at signed integers. A signed integer can be declared with the keyword int, just like uint. The keyword integer is short for a data type that will store 256 bits of memory, integer 256. Since an integer is signed, the range covers both negative and positive numbers. Let's compare the range of a uint to an int 8. Okay, so it's still 256 things. It's just the range of it. Uint 8 looks like it's going from 0 to 256, and we're just shifting it over. So it's still 256, I don't want to say bits, total numbers, but the range of its slides, it's a sliding range over. So it goes to int 8. Integer 8, it's still 256 numbers. You just limited, looks like, from negative 128 to 127. So, and it says here, look, we still cover 256 values, which is true. It's still be expressed with 8 bits, but we now consider the negative difference. I don't know how to write that in binary, but maybe it'll tell us. So create 3, because I only said that because I'm curious if there's a negative symbol in binary, or is it a whole different binary thing when you talk about a negative number? Super curious on that. Nerd moment. Let's find out. Does binary do negative? How does it note negative? I'm trying to look at that while I'm typing. How does binary show negative numbers? Let's see. The leftmost digit of the, okay, so it was that. That's how it shows a negative number. That leftmost digit. Interesting. So interesting. That is so cool. So it's still the same number, just the leftmost digit. So, okay, cool. Nice. It's pretty awesome. That's pretty awesome to learn. Okay, so your goal, create signed integers. We want to store 3 variables. I imagine we're going to have to do the public deal. So public A, int 8, public B, and difference. There's going to be an int 16. Int 16, public difference will be A, I imagine, minus B. Okay, so declare. One of the values must be, I don't know if we have to declare anything here or if we could just run it at this point. Let's see. Ooh, we almost got there. We got past one test, not the other. All right, so what do we got to do here? You can get the absolute difference by simply applying. Wait, what does it want to do? Declare the difference, which is the absolute. I see. The negative number. So they're not just an absolute deal here. No, there's no absolute method in Solidity. Okay. Won't that add them, though? The absolute difference would be 25, which is 10 minus 25. Yeah, I guess that would be that. So it doesn't work, though. The difference of A and B is not... Guys, this is going to be another user error. Golly. Okay, let's see. Oh, it wanted us to hard code something, it looks like. Okay, well, let's fix that real quick. So we'll say 5, and then maybe I didn't read the full directions. I more than likely did not. Okay, so we have 5, and the difference would then be 10. Let's try. I'll just totally cut this part out. You know, first take Drake. No. Okay, all right, we'll keep it moving. Imagine I just cut out all the mistakes I make. I do have content that where you know I like try to really refine, like the 2-minute talk videos. I really refine. I write the scripts for. I take many takes. But learning in public, this is something where I do not want to touch it, because I think a lot of tutorials and I think there's this weird toxic space, and this might be a bit too much of a talking point, but there's this like thing, you know, especially when I learned software, my first bits at it. I'm still learning software, you know, it's a lifetime thing. But I was under this impression of like, this is how fast people really write software when they're like building the full, you know, front and back end solutions. It's like, oh, it's only a 30-minute thing to build that much software. Like, no, it's like you're wrestling with each feature or like many of the features and how they work. And then you might still be really quick at it. You might be getting it down pretty fast. You might have known what you're doing, but but it's like, I think the real proper messages have both of those things. Okay, here's how to build this thing, but then here's how to learn how to build that thing. Here's how to learn the skill sets associated with that. And that's kind of where I'm trying to live, is like by the time we're building full on smart contract front end, huge web applications with brilliant transactions and this, that, the other, we're going to be pointing at this series of, or just all of my learning stuff that's just really wrestling with learning on a boring, let's look up how binaries handle negative numbers type thing. So it's a fun place to come hang out and learn. You know what I mean? That's what we're about over here. That's what we're about. So no shot to those other guys too, because they obviously, they're very, 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 very smart too. So. But anyway, okay, so we can create strings of characters using double quotes. The string literal hello world is perfectly valid in Solidity. You'll often see fixed values described as a literal. The string value hello world can be described as a string literal, which differentiates from a string data type. Any fixed value could be a literal, hello, 42, or true. A string literal can be stored both in bytes and string types. So we have bytes or string. Cool. Message 1, message 2, it's the same thing. For a long human readable message, it is recommended to use string, since it will be easier to read the values from the blockchain storage from the outside for a front-end application. If the string is shorter than 32 bytes, it is more efficient to store. How do we know how many bytes? Okay, but it's more efficient to store it in a fixed byte array, bytes 32. This simplifies the computation since the memory is allocated ahead of time. Okay, so on the other hand, both string and bytes were allocated with their memory dynamically depending on the size of the string. How many characters can be stored in a byte 32? I just asked that. I swear I didn't pre-read this. I promise I did it. Well, this actually depends on the characters themselves. Many characters in UTF-8 encoding can be represented with 1 byte, while others are represented with several bytes. For instance, C is encoded by 0x63, while C with the ampersand, or what is that? The C accent thing is encoded by a completely different number. So that's kind of what I was asking with the binaries. Is it a completely different number, or is it just the same number with just one extra thing? And it looks like here, it's not the same letter with just one extra thing. It's a completely different hexadecimal value. So the maximum values would be, when you add up all these hexadecimals, looks like there's a fixed amount we can do of bytes. So this would be, I guess, 1 byte is, so we have 1, 2, 3, 4, 5, 6, 7, 8, I don't know how many bytes, guys. Bytes, maybe 32 bytes. And this would be, here's 4, here's another 4, here's maybe 16 or so. Maybe it looks like 16 versus 32. That would kind of roughly make sense. Adding a character into either string will result in compile time. Will result in a compile time error since the string literal would no longer fit into 32 bytes. So we cannot store this into, or we can store that. We just can't add anything to them because they're at the maximum of their data thing. So quite often the long strings are stored separately on distributed services, IPFS, hash representation stored on the blockchain, since storage on the blockchain is expensive. For example, you could write a legal document and hash the contents along with a digital signature to prove that it was signed. As long as the original document is preserved, it can easily be proven that it was signed by rehashing the contents. So you have a document that you, after you send out a copy, or at least this version of the copy of the document, version 1, you now have your signature. Mine would be like Ryan's wallet, right? Let's just pretend it's just a name. Let's not do hashes. But I could take document version 1 and Ryan's name and hash them, put them through a hashing function. And let's say all the hashing function did, this isn't what hashing functions do, but let's pretend all it did was just add document 1 to Ryan's wallet or Pag's wallet. And that way I can just store that now. I don't have to store the document. I don't have to store the digital signature. I just need to store the name of the document and Ryan 1 onto the blockchain to say, no, this is what we signed for, this is it. And keep the document somewhere else, way over here, in cold storage and a cloud storage and your own, DB, Mongo non-relational storage, DynamoDB, something like that, completely unrelated. And any time for a legal thing now, you could say, no, we did sign that. Here's proof. If I pull out version 1 of that document again and I sign with Ryan's wallet, we get the same exact hash. So that is what I'm understanding is going on here. And then every time we update the document, so you always keep document 1 And if you need to update it, you need to make a change. You copy it, you make a new document, so document 2 or document 1.1 or something. That's what you now work with if you need to do more signatures or something different. But now if you hash document 1 with Ryan Wallet, it's as good as gold, and it exists on the blockchain. We have that data for a very long time to come. I have no idea what IPFS is, so let's read about it for a sec. So let's discover what IPFS is. Looks like we're getting some shield stuff, some sketchiness from this website. IPFS versatility shines across different industries, making it the multi-purpose tool for the decentralized age. Okay, our peer-to-peer content delivery network is built around, let's not read all of this, but just let's get an idea of what IPFS is. The IPFS network is distributed and participatory, so it reduces the problem of data silos. We'll just have people over here. We can verify data. It looks like it's resilient. Retrieve and locate the data based on the fingerprint of its actual content rather than the name of it or its location. Cool. So is it a little bit like sharding a database, kind of? Sharding a database is like, here's all my data in America, and I'm like, here's Central of America, and let's keep some data over here, some data over here, some data over here, data over here. So data for the West Coast people can maybe be on the West Coast, data for the East Coast people could be on the East Coast. That's sharding your database. Is like, okay, so now if I'm on an East Coast server, now my people on the East Coast have a lot less space to access the data. It's a little bit quicker potentially than if they had to reference their data elsewhere. So that's a bit what sharding could look like. With load balancing, a few other things, but like load balancing is just, golly, I need to make a video on load balancing, but in reverse proxies. But okay, so let's get back to our thing. So IPFS looks like it's some sort of data sharding looking thing that helps us distribute data based on, and we can access that data based on the actual fingerprint of the data. So if we did that contract with Ryan's wallet, looks like we could just look for that piece of data, that Ryan wallet contract 1 hash. It looks like we could access it. So I'm only breaking it down this granularly, guys, because we are going to have to know this stuff. Just FYI. So we're going to move slow. We're going to move left row. Slow and left row. Okay, so it's time to do the hello world string in Solidity. Create a public bytes storage. Okay, so we'll say a bytes 32 for message 1, and it's going to store the string hello world. Cool. We got one down. Create a public string storage. What is it? Create a public string storage message 2. And what is it going to do? String literal that requires over 32 bytes to store. So we can take one of these that we know is 32 bytes and just pop in hello or hello world right at the end. So just to differentiate the data types. What the heck? Okay. What did we break? Oh, public. Forgot the public, guys. We're gonna have to get in a habit of doing this. Sweet. Okay, let's break this real quick just to see how much it would take to break. So if we have this CCC thing, will that break the? Let's make it another message real quick. This should break the code. Sweet, it does. Awesome. But it doesn't break it for the reason why. What is going on? Whoa. Does it automatically? It won't let you store more data? Is that what's going on, or is my computer just being weird? It's got to be my computer being weird. I was going to say that's way too fancy for a language but that's a good idea actually for writing a language. Is like, don't even let the person write the language. That's actually a really good idea. Okay, so the code is running. Let's see if it breaks it. It should. Let's put more bytes in here to see what breaks. Okay, sweet. That's when it breaks it, when it's too many bytes. Okay, cool. Just want to get that granular understanding of how stuff works, how it doesn't work. We want both understandings. So let's move on to the next bit. The enums. Enum. The type enum helps us write clean code. Consider this example. If a player dot movement is equal to 0, player's moving up. We've denoted the direction 0 is up. And then let's pretend 1 is to the left. Okay, so looks like we have some things that, okay, let's just read it. So these comments are helpful, but they aren't foolproof. The movement number is being generated somewhere else in the code. So that's like having an analog D-pad and you press left, and instead of you passing a string that says left, you're passing the number that says 1, and then you just write a comment. So it's that's what they're highlighting here. It's not exactly a foolproof plan. Okay, so plus without the comments, there would be no way to tell which direction the person is using. So we have a enum where we can append our own types and now say directions up, left, downright. And I know this is going to be choice next. I have a feeling we're going to be learning about choice as well. So an enum, we can build whatever type we want. We could say, like, let's pretend we're building a contract for a restaurant, right? And maybe it's menu items, right? Well, they have foods here. Maybe we're building a contract for a city, and the city's building restaurants, right? And we could have, well, we have all different types of cities or type of restaurants. We have Applebee's, we have Chick-fil-A, right? We have Chipotle. So the enum is saying, obviously there's no data type for an enum. We can't put that into a uint. We can't, I guess you could do that as a string of, or an array of strings, but that is a bit about an enum. It has to be one of those types. If you want to be in our city of Chick-fil-A, Applebee's, and Chipotle, you have to be one of those restaurants. Okay, so that just helps us write clean data. We're going to use that so much cleaner. So not only are the numbers replaced with clear directions, we also have a structure for defining all our directions. We can share the structure directions with other contracts to ensure that if the numbers change, they won't break the rest of the code. Sweet. So that's why we do these type data things, because you're building your data models. And as long as everybody adheres to the data model, the code should still keep working. And unless we do the Liskov principle, which there's solid coding dynamics or practices, the SOLID coding practices, and I'll make a video on that stuff here shortly as well. But those are good things to do. But that's basically, you can stick to a design pattern, but then you can embellish upon it, is the Liskov principle. But you cannot change the old pattern, or should not. You can do whatever you want, but you should not. Okay, so your goal is to make some food. In the enum provided, you'll see that there are 4 types of food: apple, banana, pizza, and okay, so take the values of them and store them in food 1, food 2, food 3, food 4. Okay, let's do this, let's do this, let's do this, and see what we got. Do we store them as strings? Oh, I forgot we need to access them. So foods.apple, foods.pizza, foods.bagel, foods.banana. Let's see if that works. Alrighty, I think so, guys. Sweet. Awesome work. We went over booleans, unsigned integers, bytes, strings, and enums. Quite a lot of Solidity to learn. I agree. Awesome. Well, I'll wrap it up here, guys. I said, this is a great approach to Alchemy University, or to learning Solidity, and they have a ton of material as well. So yeah. But I will be grinding this out with consistency, and yeah, I enjoy learning the blockchain stuff very intimately. So let's learn it together. I will see you on the next episode. Cheers.